In this video, we'll talk about the electrodiagram, or sometimes it's known as the ECG or the EKG. And what does it do? It tracks the electrical signal of the heart. So how this action potential is progressing through the conduction system, the ECG is measuring that. The way usually it's performed, they will connect the patient to leads, so they call them leads. So sometimes they are using a simple one like with 3 or 5 leads, but sometimes it's more complicated like 12 leads that will give different types of information. But all of them basically are looking for this, for the ECG. We will try to spend some time to understand what does each of those letters mean, what is the interval, what is the segments, and so on. So let's do some drawings. And we'll talk about also basic stuff before we move to the ECG. Okay, so remember few things. We have the heart, we have the atria, we have the ventricles. The action potential is moving from here, and then to here, right? This is how the action potential is moving. The SA node and passing through the AV node, the AV bundle branches to the Purkinje file. And we understand the action potential is like composed of 2 steps, the depolarization, then the repolarization. So since we are starting from the atria, then we will have, if you want to list who is going to depolarize and repolarize between the 4 chambers, we will have the following. It will be atrial depolarization, then atrial repolarization, then ventricle depolarization, followed by ventricle repolarization. Okay, so each area got depolarized and repolarized, depolarized and repolarized. What happens after ventricle repolarization? We'll start again. So the ECG is technically documenting those steps. So this is the ECG. This is how it appears: P, Q, R, S, and T. P, Q, R, S, T. This is the same order in the alphabet. It's called the B wave and the T wave and the QRS complex. QRS complex. So what does each one of those peaks mean? What we will try to match those processes with the ECG. So we said the first step is the atrial depolarization. And the first step here is the P wave. This is the first thing we will see. So the B wave, it means atrial depolarization. Okay? And technically, by the end of the B wave, it means the atria are both depolarized. It means also that the SA node sends the action potential. If we see the B wave, it means that we have an action potential sent from the SA node. Then the QRS complex. The next step, if we have atrial depolarization, the QRS, it means atrial repolarization. And also it means, and we will see some details there, ventricles depolarization. And then the T wave, since we have ventricle depolarization, it means ventricle repolarization. So those are the basic information about those steps. The B wave is for atrial depolarization, QRS atrial repolarization, ventricle depolarization, and then we have the ventricle repolarization in the T wave. Now, we have additional details that we can add about this. We have the area from the B wave to the R, to the middle of the R complex. This is called the BR interval. What does it mean? It means that this is the time needed for atrial depolarization and repolarization. So by the R, the atria are completely repolarized. By the R, the atria are repolarized and completely relaxed. Okay? Then we have an area between the Q here and the T wave, the end of the T wave. This is called the QT interval. And what does it mean? This is the time needed for ventricles depolarization and repolarization. So between Q and T, that is the time for the ventricle. Between the B and the R, this is the time for the atrial. But here, in this area, this overlap, here the atria are repolarized and the ventricle are starting to get depolarized. Okay, so there is no like double contraction or something. Okay, then we have 2 lines. We have this line, a straight line, straight line, it means no electrical activity in the heart. No electrical activity, okay? This is different than saying no action potential, okay? Those two are two different things. No electrical activity, it means maybe there is an action potential, but during, for example, like either depolarization or repolarization. This is not rest. The straight line doesn't necessarily mean a rest. We will call it the BR segment. What is happening, this straight line is, what does it say? It says that there is the AV node holds the action potential. So this is the delay at the AV node. This is the delay at the AV node. Okay. Then we have the ST segment, which is this line. This line technically should be much longer. Okay. Should be much longer. This is the plateau. If you remember when we talked about the action potential, the plateau, this happened here. And I made a mistake that the ECG should be like this, a little bit longer. Okay. This period is the plateau. Okay. Make sure you understand this. So this is the ST segment. Then we have a third straight line, which is from the T wave to the B wave, like between the two ECGs. And we'll call it the TB segment. Here, what does it mean? No action potential in the heart, and the heart is ready for second or coming action potential. So this line here, it means no action potential. This is the rest, the heart at rest or completely repolarized. Okay? So all of those are the different parts of the ECG. This will show you the progress of the ECG here with the events. Where is the electrical signal? See here that line was at the AV node, then the QRS, we are depolarizing and then repolarizing the ventricles. Okay, so now the T wave is repolarizing the ventricles. Now, just be careful. The ECG here, it does not mean the contraction. There is the delay. Always there is a delay. Okay? See, the contractions here in the atria happened during this period. Then see the QRS complex. Until now, there is no contraction. Now they started to contract. And after the T wave is end, that is when the heart is relaxed and we have the AV valves open. Okay? So look at this image several times, so you can grasp a concept or the general idea of how this action potential is progressing versus the contractions of the heart. And this is what we will try to understand in the cardiac cycle here, and like a still image of the same issue. Where is the B wave? Where is the actual action potential? What do we have here? We have atrial contractions. That is during the BR segment, because the signal is held at the AV node. Then we have the QRS complex. It means that the atria are repolarized, the ventricle started to depolarize. Then during the ST, that is when we will have the plateau. So now we have a contraction of the ventricle muscles. Then the T wave, by the end of the T wave, we have complete repolarization of the ventricles, and the ventricles will start to relax, and now they are ready again to start over. Okay, so that is the progress of the ECG, and how do we overlap it with the electrical progress or the progress of the electrical signal through the heart. And in fact, I want to show you this image. This shows where are the events, the electrical events, and where is the contractions. This is for the atrial contractions. This is for the ventricle contraction, right? So here is the atrial action potential in the muscles. That's where you see the depolarization of the atria during the B wave. Then there is the plateau. We have the hold, right? Then the repolarization at the almost the middle of the QRS complex. At the same time, in the middle of the QRS complex, we have the ventricle depolarization. Remember, we said the QRS is for atrial repolarization and the ventricle depolarization. So we will have the depolarization, then we will have the plateau, which is the ST segment, right? Then we have the T wave, which indicates the repolarization of the ventricle, right? Then to the TB segment, which means that there is no electrical signal in the heart, and now the heart is ready for a new action potential. So I will stop here, and the following video we will talk about the cardiac cycle.